like to make a really short video for Math 1052, a little addition to some of the algebra topics from the first unit. In particular, I just want to look at factoring some expressions. So there's an example of a factored expression at the bottom of this slide. And to be honest, there will most likely be a factoring question on your test. And why else might you be interested in factoring? Well, later on in Unit 3, when we talk about merchandising, there's some questions where we need to solve for a variable that appears in two places in an equation. And one way to isolate that variable will be to put it on the same side and then factor. In this case, the factoring is very similar to just collecting like terms, but there are other situations where we don't have any numbers involved where you're solving for a variable by factoring alone. So I've already used a couple of these words that are important to understand algebra and factoring. I'll just throw these slides up, and if you need to pause and read through some examples so that you are familiar with the vocabulary, then you can do that. But I'm not going to spend a lot of time on what variables are or constants are or coefficients, although the coefficients are important when we're talking about factoring, so you might hear me use those words later on. Additionally, of course, I'm talking about algebraic expressions today, so if that's new to you as well, you can have a read of some examples or watch the 1052 video on that topic. I'm not going to spend a lot of time on the background of that, other than to say that when we're factoring, we have to look at the individual terms in the expression, so that might come up as well. And I already said collecting like terms. You can think about like terms as being, you know, an X in the first term, an X in the second term, apple, apple, they're alike, orange, orange, they're alike. But the very bottom example here, you'll notice that we have an apple and an orange, or an X and a Y. And because of that, actually no factoring can be done here. It looks exactly the same as we started out with. So that is important as well. Moving on, the opposite of factoring is actually just multiplication. So I'll briefly mention multiplying expressions together first so that you can see how that works in reverse, which is factoring. So we need to be multiplying terms. There'll be one term in front of a bracket. And so when I'm doing that, I'm multiplying numbers with numbers, and I'm putting the letters with the letters as best as I can. So I think this is best seen with an example. If I'm talking about simplifying here, we're actually talking about multiplication. So my monomial in front is just a 3, and the polynomial in the brackets is the 2x plus 7. The brackets implies that I'm multiplying the 3 on the outside with everything inside. And so, since it's just a number on the outside, well, I'm multiplying the number with the number. So the 3 times the 2, and the x remains. Okay, it's unlike, but it has to stay there. And so that gives us, of course, 6x. And then the 3 with the 7, no surprise, is going to give us 21. So that is the opposite of factoring. That's expanding. We actually started with something that was already in factored form. We can do this with more than just a number in front, a number and a variable. So in this case, I'm multiplying 5x by 2x. So I'm multiplying the number with the number, the 5 and the 2, and I'm multiplying the x and the x, which, be careful, is x squared. And so I end up with 10x squared together as my first term. Then I have to multiply that 5x through with the second term, keeping note of the fact that I have a minus sign there. So that's a negative y. So that negative sign has to stay. You can think of it as -1 if you want. So then I'm multiplying -5 and -1. And I have an x and a y. I can't really put those together other than to write them side by side. So my fully expanded version is 10x squared minus 5xy. And that is kind of the opposite of factoring. So now we want to do this in reverse. Okay, so I'm going from what's on the right backwards to what's on the left. So let's look at a couple simple examples. Take a moment to write these down so that you can try them along with me. I'm just going to switch over so that it's an easier format for me to write. Okay, so for our first example, I want to write this as two things multiplying together. I have 10 AC minus 5 BC. I want to write something in front, a single monomial or a single term in front. Remember, numbers with numbers. So I have a 10 and I have a 5. technically a -5, but let's just look at the 5 for now. So I want to do the opposite of multiplying. I want to divide. So I'm trying to divide each of these numbers by the same thing, the biggest possible thing that I can divide them both by. So in this case, obviously, that's a 5. I'm going to divide them both by 5. In doing so, that means I need to write that factor in front of the brackets, okay? I'll explain more with that in a moment, but let's move on. Next, I'm going to look at the letters after each term. Or in each term. So in the first one, I have an A. In the second one, I do not have an A. Okay, I have a B. Fine. That's all well and good, but they're not common. They're not like. So I'm going to keep going and look at, okay, I do have a C in both. Great. So in a similar fashion, technically what that means I'm doing is I'm going to divide out the C. To show that it's been divided out, I'm going to write it in front. Okay, so now we're left with what goes in the brackets. We started with 2 terms, so we had better end with 2 terms as well inside the brackets. So now I look at what I have simplified here in my first term. So I've taken 10 and I've divided by 5, so that leaves me with a 2. And nothing happened to A. A is still there. I divided out the C. C divided by C, well, you can think of that as being 1. And we don't usually write 1 in front when we're talking about variables. So I'm going to leave that out. Next, noticing I had a minus sign before, so I'm still going to have a minus sign. I'm looking at the second part. Technically, I'm dividing 5 by 5, which, as I said, is going to be 1. And we don't usually write 1 in front of our letters. Same with the C, divided by C, which means by default, I'm left with nothing but the 5 here. So I'm just going, or sorry, nothing but the B, just the B. So I'm going to put the B there. And if you were wondering, how can this be? We can check. So let's go to some space below and let's just check and make sure that we did this right. So remember, multiplying and dividing are opposites, or multiplying and factoring are opposites. So we just did the factoring. Now I want to go in reverse and double check. So is this going to give me what I started with? Well, I'm going to multiply through. 5 times 2 is 10. The C and the A I can't do much with. I usually just write them in alphabetical order. And then moving on, keeping in mind that this is like a -1, so I'm multiplying -1 by 5. So I have -5, and B times C, well, they're going to stay. So I do, in fact, end up with what I started with. So I know I've done this correctly, and that's the great thing about factoring, is you can always check your answer. I will do one more with you. Hopefully it looks a little bit familiar. Again, we have some common things here. I don't need to spend much time on those coefficients since they're the same as the previous example, so clearly we're going to divide out the 5. But I do want to focus on the next part. So now I have an x squared, and technically this is x to the power of 1. So the biggest thing I can divide out of both of them, even though I can divide out 2 x's from the first, I can only divide out 1 from the second. So the highest common factor is that I can divide those each by x. Okay, so that means I'm going to put an x here. Clearly that y is only in the second term, so it is going to remain. So that being said, we're almost done here. Now I just want to look at what x squared divided by x would be. You might use your exponent rules here, or you might just use some common sense here to see that I'm going to be left with 1x alone. Keeping in mind I still have to take the 10 and divide by the 5, which will put a 2 there. Okay, and then my x. And 5 divided by 5, leave the negative sign there. X divided by x, just 1, and I'm left with the y for the second term. And hopefully that looks a little bit familiar, since that should be, this part should be the opposite of what I just did in the expanding slide. And what do you know? It is. So that is one way you can check. You can always check these answers. If you wanted to try a couple more, you can have a quick peek at my last 2 examples, keeping in mind, of course, that nothing new is going on here. just extra practice. So pause the video, try it out, check with my answers. This one goes a little bit faster, keeping in mind that what I'm writing in front of the brackets is what's called the highest common factor. So clearly I have to look at the numbers. They both are divisible by 3 at most, so I end up with a 3. And the letter that's the same in both is the y. So that's the highest common factor. You might notice in the textbook that they go ahead and write as a fraction the division that they're doing as a middle step. You do not have to show that if you understand what I was doing. You can go directly to the last part, which is to write your monomial up front, and then in the brackets you will have 2 terms. So I have to look at what's left. All that's left is an x in the first term, and when I do the division 9 by 3, I'll have a 3. And the y, you can think of it as sort of canceling with the y, if you will. I think it'll let me write here. There we go. And that'll leave me with just z there. The last one I wanted to mention was just because we have these powers of x, they all have different exponents. The biggest x power that I can take out is going to be the smallest exponent. Keeping in mind, I also have to deal with the numbers. Now we're dealing with 3 numbers, but that's okay. I just have to find the biggest number I can divide both 6, 8, and 12 by. They're all even, so happens to be 2 in this case. And as I mentioned, that smallest exponent is going to be the highest common factor that I can take out. And inside the brackets here, now we're going to have 3 terms. We started with 3 terms. I need to divide out 2x squared from each of those 3 terms. So I know when I'm done, I will have 3 terms still inside the brackets. That's important, okay? You can't change the number of terms when you're factoring. And so if you were unsure about this, you could expand these back out and double check that you ended up with what you started with. And if you did, then you factored correctly. So that's all I have to say. Thank you and have a good day.